Now we have here the spreadsheet models. In this topic, we have the following learning objectives. Now, spreadsheet models are mathematical and logic-based models. Their strength is that they provide easy to use, sophisticated machines, allowing for easy instant recalculation for additional inputs. This is why spreadsheet models are often referred to as the what if models. What if models allow you to answer questions such as if the per unit cost is $4, what is the impact on profit? They are less so in this topic, we discuss the principles for building reliable spreadsheets. We build a conceptual model for a decision problem, how to convert the conceptual model to a mathematical model, and how to implement the model in a spreadsheet. We introduce the three analysis tools available in Excel, which is the data table, the goal seek, and the scenario manager. And we discuss some Excel functions that are useful for building spreadsheet models for decision making. And finally, present how to audit spreadsheet models to ensure its reliability. Now, building a good spreadsheet models with the use of influence diagrams, building a mathematical model, and spreadsheet design and implement the model in a spreadsheet. So let's begin with our discussion of spreadsheet models by considering the cost of producing a single product. The total cost of manufacturing a product can usually be defined as the sum of two costs, fixed cost and variable cost, in which fixed cost, a laser, is the portion of the total cost that does not depend on the production quantity. And this cost remains the same no matter how much is produced. On the other hand, variable cost is the portion of the total cost that is dependent on and varies with proportion and the production quantity. And to illustrate how cost models can be developed, we will consider a manufacturing problem faced by Nolan Plastics. Now, many manufacturers face this type of decisions, which is known as the make versus buy option. And this will be used in comparing the costs of manufacturing in house to the cost of outsourcing production to another firm. It is often useful to begin the modeling process with a conceptual model that shows the relationships between the various parts of the problem being modeled. The conceptual model helps in organizing the data requirements and provides a roadmap for eventually constructing a mathematical model. A conceptual model also provides a clear way to communicate the model to others. This influence diagram is a visual representation of which entities influence others in a model. Parts of the model are represented by circular or oval called nodes, and arrows connecting the nodes show influence. This figure shows an influence diagram for Nolan's total cost of production for the Viper. Total manufacture cost depends on fixed cost and variable cost, where this in which in turn and this variable cost depends on the variable cost per unit and the quantity required. Now, an expanded influence diagram that includes an outsourcing option is shown in this figure. And note that the influence diagram in the previous slide is a subset of the influence diagram in this figure. And our method here is to build an influence diagram for a portion of the problem and then expand it until the total problem is conceptually modeled and is usually a good way to proceed. This modular approach simplifies the process and reduces the likelihood of error. And this is true not just for influence diagrams, but for the construction of the mathematical and spreadsheet models as well. Next, we turn our attention to using the influence diagram in this figure to guide us in the construction of mathematical model. Now the task is to use the influence diagram to build the mathematical model. Let us first consider the cost of manufacturing the required units of the Viper. As the influence diagram shows, this cost is a function of the fixed cost, the variable cost per unit, and quantity required. So in general, it is best to define notation for every node in the influence diagram. So let's find the following. Q, which is the quantity, number of units required. FC is the fixed cost of manufacturing. Price unit variable cost of manufacturing is TMC sub Q equal to the total cost to manufacture Q units. Now, the cost volume model for producing Q units of the Viper can be written as PMC of Q is equal to FC plus the product of BC and Q. For the Viper, FC is equal to 134,000 and it's $2. So PMC of Q is equal to 234,000 plus $2 of Q. Once a quantity required Q is established, question 10.1 now populated with the data for the Viper can be used to compute the total manufacturing cost. For example, the decision to produce Q is equal to 10,000 units would result in a total cost of MC of 10,000. That is equals to 234,000 plus $2 times 10,000 is equal to 254,000. So similarly, the total model for purchasing Q units is shown in this equation 10.2 that let P the per unit purchase cost and PPC of Q equal to the total cost to outsource or purchase Q units. So PPC of Q is equal to P of Q. For the Vipers, since P is $3.5, question 2 comes PPC of equal to 3.5 Q. Thus, the total cost to outsource 1,000 units of Viper is TPC of 10,000 is equal to 3.5 times 10,000 equal to 35,000. We can now state mathematically the savings associated with outsourcing. Let S of Q, the savings due to outsourcing, that is the difference between the total cost of manufacturing Q units, the total cost of buying Q units. So in summary, Nowlin's decision problem is whether to manufacture or outsource the demand of its Viper product next year. Because management does not yet know the required demand, the quick question is, for what quantities is it more cost effective to outsource rather than produce the Viper? Mathematically, this question is for what values of keys S of Q greater than 0. Next, we discuss a spreadsheet implementation of our conceptual and mathematical models that will help us answer this question. Now, we have the spreadsheet design and implementing the model in a spreadsheet. Okay, there are several guiding principles for how to build a spreadsheet so that it is easily used by others and the risk of error is mitigated. In this section, we discuss some of those principles and the design and construction of a spreadsheet model using the Nowlin products make versus buy decision. In the construction of spreadsheet model, it is helpful to categorize its components.